and probably a little uncertain about the value returning. We'll go over that again, okay? We discussed arguments. I want to go into that in depth today so that you understand how to use arguments back and forth between functions. And we'll talk about what's a formal argument, what's an actual argument, and how they work. And then the one tricky thing, I believe, with functions is pass by value, pass by reference. So I'm going to start introducing that today. We'll have a lab on that tomorrow, and then you'll be able to digest that, and we'll go over it again on Thursday. Scope has to do with what? Where variables are visible. So the good thing about scope, we only have two different scopes. Global, which means everywhere in the program. We pretty much avoid global in programming. And local, which is within a function. We are calling these functions or procedures. In Java next semester, you'll call these methods. Most of the ideas that we're talking about apply across languages. Okay? So it's not a C specific, but something that you're going to use no matter what language you do. So this is an example of a void function. The two things to remember when using a void function is that this function doesn't have to return anything. It may or may not have arguments, which we're going to look at today. When you call a void function, you simply give the name followed by a semicolon, and that jumps to the void function. If I was going to do a hierarchy chart for this, how many blocks would I have in it? Just two. One that says do prop 1 and some other thing that describes which this program does, which doesn't do much, so it'll be a little tricky. But does everybody understand that when I call a function, the control transfers down here, finishes the whole function, then comes back to the line afterwards, right? That's the basic. Everybody understands that, okay? So here's a hierarchy chart. We have four functions. One is main. Demo A, dem also goes into these three is the name of the function, and then we just give a different name for the main guy because it's kind of dumb to put main there. So give a meaningful name so you can look at this hierarchy chart and know what the program does. The other kind of thing that we're doing is we're using verbs to indicate a void function. We can't guarantee that's what's going to happen for the rest of our life. Okay, so we're going to use that hierarchy chart at the beginning. As soon as we start to do our design, we're going to use our hierarchy chart, and then we're going to construct the code for each one. Main first. Main should generally always have a loop. It's kind of a good rule of thumb to go by. And then each other block in the hierarchy chart, you construct the code and test the code for. We're kind of moving away from IPOs because our programs have gotten pretty complex, right? This is an example of using an argument. All right? When I create an argument inside a function, this is called a formal argument. Okay? This is important to understand because we're going to use this in a second when we start to talk about pass by value, pass by reference. So when I declare an argument inside a function, I call that the formal argument. I hate to memorize. So the way I remember is I'm formally declaring the argument. I'm giving it a type and I'm giving it a name, just like I do when I regularly declare a variable. Does that make sense? Formally declaring the argument within the function. Okay? Now this argument is local to the function, meaning what? It can only be seen there. So num lines can be seen from the beginning of print lines to the end of print lines. Local, visible. That's where it's visible, within that function. So an argument is local, and this is an actual local variable that is defined within that function as well. Are there any questions about what I mean by a local variable declared within a function? Okay. Now, how many arguments could I put in this line? 0, 1, multiple, right? As many as I need. Does that make sense? Each one must be declared followed by a comma. So when I call this guy, when I call print line, what do I need to send to print line? It's void, so I just give the name. So what can go inside here? An integer. That's really all it cares about. You send me an integer, okay? And it will use it as num line. So I have a couple different options. One is to actually put an integer there. Well, this guy is called the formal argument. Remember? Formal argument. This guy is called the actual argument. Actual argument is sent to the formal argument. You with me? Okay. Now, that's one way of passing an integer. What's another way of passing an integer? A variable. So long as the variable is what? Integer. The only thing that matters when I call send it an integer. Does that make sense? Either a known integer or something I've read a value into, but I'm going to pass that integer into print line. Formal argument is where I declare it. Actual is where I send it. You with me? So here's an example of sending it to num lines. So then this guy will print 2 lines of stars, right? Or if I send a 4 to num lines, it will print 4 lines of stars. So this gives me some power to send different values to the function. Here's the same thing that I've just been talking about. This guy is formal. This guy is actual. Could I do something like this? Can I send num plus 2 to the, of course, so long as it's an integer, the actual can be a number, a variable, or an expression, so long as it's integer. Does that make sense? Okay? Now, if I have no formal arguments, then how many actual arguments do I send? 0, right? So the number and type of the formal and the actual must match. Does that make sense? The number and type of the formal and actual must match. In this particular example, I've added another argument, and this is a character, so I decide what I want the character to be printed out as. So that means the second argument must be a character type as well. All right, so a value returning function is not void. It has arguments. It can have 1 argument, 0 arguments. The arguments are the same in value returning and void functions. Okay? So the arguments, formal and actual, same rules. Make sense? The difference between the value returning function is that it's not void, but instead it has what associated with it? And these are both in, but it has a type associated with it. So in the case of print lines, it was void. It doesn't return anything. Value returning does what? Returns a value. So the type associated with that function is the type of the value returned. If I'm going to return an int, the type is int. If I'm going to return a float, the type is float. If I'm going to return a char, it's char. Boolean, all these can be used for types of value returning functions. Does that make sense? Okay, so the deal with value returning is they're usually short and sweet. Because I told you that most value returning functions are what? Mathematical. Most value returning functions are mathematical. Not all, but many. Okay? So, in the case of cube, this guy takes the value and returns what? The cube of x. Okay? This was the problem we ended with, if you remember, last Thursday. And we pass in 2 numbers, and we determine which one's larger by placing it in max, and then the last line of this function returns max. So if I ask you to write a function called product, go ahead, try it. You give it the name product. You give it the type, let's assume int, we're doing int, so let's stick with int. And what would your arguments be? 2 numbers coming in, x and y, num1, num2, whatever you want to do. The type would be integer, okay? So then there's 2 ways we can write product. So we have int product. It has 2 numbers coming in. One way to write it, and it's up to you, whichever one you feel more comfortable with, is just to say return x times y. Another way, some people like this better. If both, it's up to you, whatever you feel more comfortable with. There's not really an advantage or disadvantage of either one of these. Okay, so that's writing a value returning. They're easy, right? Short and sweet. They do the math, return the answer. The trick is calling a value returning function. Okay? So remember, I was trying to remember the little ditty. I don't know if I have it in my notes or not. The way if we're going to call value return, we're going to do one of 3 things. We're going to store it, use it, or print it. Now let's look at what happens if I try to call it without doing that. So let's say that I just do this, product. What's wrong with that call? Nothing. It's lost in space effectively. It's sort of like saying 2 semicolons, right? Does everybody see the problem? So let's say instead I say int p. Now this time I'm calling product, I'm getting the answer, and storing the answer into another variable. The trick is, don't just call a value return returning and don't do anything with it? Well, my answer is lost in space. Okay? Now, the other option is to include it inside an expression. So the advantage is I can plug this guy, just like a mathematical function, right inside an equation. Okay? And the answer will go right here, add b, and then store the thing in y. So I didn't have to do 2 steps. I didn't have to call it, put it somewhere, and then use it. So this is an example of using it. Storing it directly into a variable, using it inside an equation, or the last one is to print it directly. Does everybody see the difference between that and a void function, calling a void function? A value returning function has an answer. We plug it in somewhere and it has a value. We just put a semicolon after it, it's lost. Not all value returning are mathematical. I want you to try to write the following function. Is positive. It has one argument. What type should that guy be? Boolean. It has one argument of type integer, and it's going to return, if it's Boolean, it's going to return what? True or false. Okay? So go ahead and try to write it. We're writing is positive. Yeah, we're going to make it equal to also. Does that make sense? Okay? So that means answer equals true. Else, if it's not positive, answer equals false. And what does the last line of a value returning function have to do? Value returning, hint, hint, return that value, which in this case is and. So it's going to be, did everybody write this? If x is greater than or equal to 0, ans equals true, else ans equals false, return ans. Okay, cool? Everybody knows how to write this value returning function. Now, how do we call this sucker? That's the trick. Well, where have we used Boolean stuff in our, we don't really want to print true or false, right? But don't we use it with like an if? Right? So couldn't I say if is positive, num, whatever, CL. What about if I want to have a while loop? While is positive, X. Okay? So Booleans can be plugged into loops or selection statements. So it's not uncommon to do that. You can use it for things like that, checking validity, checking positive, checking negative, checking even. Okay? So numeric or arithmetic and Boolean are the two predominant uses of value returning functions. There's also a lot of built-in value returning functions in all languages. There's a power function. Since we don't have exponentiation, there's a power function that's there's many built-in math functions in C++ and Java. Okay. Questions so far? All right. So we're going to practice more with that, but I want to introduce the last topic so you kind of hit everything. And that is that I'm going to talk about 2 different ways of returning arguments. This is the hard part. This is the one hard thing. Not hard, impossible, just a little more challenging. All right. So let's look at a function such as, this is a void function. It's called getTemperature. Now, what is different about getTemperature versus one of the functions I've done, like, let's say that I want to convert temperature or something like that. Why do you think I have an ampersand on getTemperature? Any ideas? Why that might be different?
It's like a reference parameter.
Okay, that is exactly right. This guy right here is a way that we specify that a variable is passed by reference. So we have two methods of passing, or let me explain the two. The default method for passing arguments in C++ is what we call pass by value. So if you don't do anything, everything is passed by value. Actual argument is copied into the formula. So if I write a function,
All right, so if I write a function called, get, I did get. Okay, so let's say that I write a function called print dimension, and I'm going to pass it length and width. That means that here's print dimension, and I'm just going to print the length, I'm going to say, what are these guys called again? I forget. Those are called the formal arguments, okay? So I wrote a function called print dimensions, and I'm going to pass it the actual arguments, which let's just say I assign. This is kind of dumb, right? I need to prototype this guy, and I need to include everything at the top, right? Okay, so this is just a simple, so what happens in this case, and I'm going to draw a picture for you just so you see, because we're about to mix this up. When I have print dimensions, it's a function that's sitting here, and it has length and width. And then I have main, and what are the two guys that main has? So when I put a 5 into L and a W into 7, and I then call it, what did I say that the formal argument's a copy? So what does that mean length gets? 5. And what does that mean width gets? 7. That's what I mean by a copy. Okay? So the actual arguments are copied into the formal argument. Okay? So if I print them now, what if I do the following? What if I add 1 to length and I print length afterwards? What do you think my output's going to be? All right, so if I ask you this question on a quiz, before I write this, what is the output for this problem? But I can name these guys whatever so long as they're declared in here. I'm purposely doing that, okay? All right, L and W are local to what? Main, okay? So they're only known in main. All's print dimensions wants is 2 integers. I can call them, Tom and Joe, doesn't matter. It takes the first guy that you pass it and puts it into length, copies it into length. The second guy you pass it and copies it into width. All right, so what's going to be the output? If I pass this 5 and 7, let's do this. Let's put this guy up here. So I'm going to print length and width. And then I'm going to copy. So what am I going to get for the first chip? What am I going to get here? If I send it a 5 and a 7, what is length and width going to be here? Okay, and then what is length going to change to here? What is length in L and W going to be here?
so this guy's going to print 5 and 7 when I first get here. When I increment length, where am I going to increment it? Just here, right? So this guy will be 6. Does L change? No, because this guy was passed by value, which means the actual argument was copied to the formal argument. Are you with me? Okay? Let's say, let me run it just so you believe me. Incremented length inside the function, but when I got back up, it's still 5 and 7. Does everybody understand that? Now, if I do want it to change, and I use this, we have to do it both places or it won't work. I want to show you the difference of what happens if you change something so this guy originally was passed by value. So pass by value, don't forget, pass by value means that the actual arguments were copied into the form. And that's the default method. You do nothing, everything's passed by value. Let's look at pass by reference. I want you to remember that reference means address. So watch the difference. When you pass something by reference, this guy, ready? The formal argument gets the address of the actual argument. And this guy is also passed by reference, okay? So when I first get here and print out length and width, obviously they're 5 and 7. When I increment length, which length am I going to increment? The guy I have the address for. So I change it there. The actual formal argument knows where the formal argument lives. I said that wrong? since the formal argument knows where the actual argument lives, it can change it. Okay? With the address, you have the location and you can change it. Alright? So if I now print, what do you think I'm going to get?
What's my first output going to be? First, it's going to print what? 5 and 7. What's it going to print here? 6. And when I get back up here, what are A and W going to be? 6 and 7. So let's say that I want to write a function that's a swap function. So basically, what I've got, this is the lab tomorrow, so pay attention, okay? So in lab tomorrow, I want you to write a function that takes 2 variables and swaps the content. So if I have x, which has a 10, and y, which has a 5, and I ask you to swap these two guys, so that y has a 10 and x has a 5, any idea how I would do that? Let me give you an example. You have your favorite mug, and you have a roommate, right? You have your favorite mug and your favorite beverage. Let's pretend it's apple. Okay? Alright, so you like apple juice and you have your favorite mug. Your roommate likes orange juice and he has his favorite mug, and somebody inadvertently poured the orange juice into the wrong mug. How do we solve this problem without violence? How do we solve if you want to swap the contents of the mugs without violence? We need another mug. We need another mug, right? So, if I want to write a swap function, I have x and y, which are the arguments, and I have a temp guy. So what I do is I say temp equals x, x equals y equals temp. Okay? So what that does is, it says temp gives 10, x gets y gives temp, and voila, they're swapped. Okay? Does everybody agree with this algorithm? Whoops. What do I do? Temp equals x, x equals y equals temp. Peachy keen. There's my swap. I think that I now want to have call swap. I'm going to ask the user for A and B. Prototype this sucker. Okay, so I'm going to enter a 5 and a 10. But guess what? It didn't swap. So is my algorithm working? Let's check by adding. So here's one of the number one things you can do to kind of see what's happening in your program. Let's put some cout statements inside our function to see if it's working the way I think. Maybe she lied. Maybe this lady doesn't know what she's talking about. So let's see if it's working inside the function. So I'm going to print what x and y are when I get them. I'm going to print what they are after the swap. And I'm going to try it again. The function got 5 and 10. And it swapped it to 10 and 5, but when I came back to main, it didn't swap. So let's see what's happening now. So main has what? A and B, right? Which I put 5 and 10, is that right? Swap has what? X and Y. So what happens to pass by value? I forget. What happens to pass by value? So x got 5, y got 10. I swapped them. But what happened to A and B? Nothing, because it was passed by value, meaning they were copied. So what should I draw? Pass by reference. So every single variable in one pass by reference has to be, okay, I could have 10 variables, one could be passed by reference, but if I want it to be changed within the thing, then I have to put in my own individual ampersand for that one. But there's no reason you can't mix and match inside. Yeah, okay, I know what you're answering. And that's actually, we didn't get to this, but okay, so 5, 10, and this time, in fact, it did. Let's see why. Let's see why it worked. So, what did it get in pass by reference? What did it get in pass by reference? What did X get instead of a copy address? So X got the address of Y.
Capiche? Y got the address of B. So when I put, forget what I did, temp gets X, so temp got 5, X got Y, so what happens, this guy gets 10, and this guy gets 5, so what did I do to the actual variables that I set? Okay? I changed it. So for a short answer to a long, a short question, a long answer, if you are changing the actual argument, you need to use pass by reference.